Hello, today we want to look at current divider rule. It is a rule that helps you calculate a branch current along a resistor. Okay, when you have two or more resistors connected in parallel. Now, if you remember the rule for the flow of current, once current is coming from an EMF source, once it gets to this junction or node, it branches off into two. One goes up called I1, the second one goes this way called I2. So we can be given the current. Let's say the current coming from this EMF is 15 amps, and these resistors R1 and R2 have values. You can quickly use a formula from the current divider rule to help you calculate either the branch current I1 or I2. Okay, but what we know for sure is that at a given point, an incoming current will be split. So which means current I is equal to I1 plus I2. That's a fact that we know from resistors in parallel or parallel connection. Another fact that we know for parallel connection is that the PD across the resistors are the same. So the potential difference across this resistor R2 is the same thing as the potential difference across this resistor R1. Potential difference is also the voltage drop. Okay, so the voltage from here to here is the same thing as the voltage from here to here, which is also the same thing as the voltage from the EMF source, okay, which is V. So the first formula we're going to use to help us carry out this calculation, all right, so this is what we have. We can decide to make R subject of formula by looking for the LCM of this. So if we do that here, that gives us that 1 over R is equal to the LCM is R1, R2. R1 cancels R1, R2 multiply 1 to give us R2. So this is R2 plus R2 cancels R2, R1 multiply 1 to give us R1. So to make R subject of formula, we can reciprocate both sides. So if you reciprocate this, it becomes R over 1, which is R. If you reciprocate the right hand side, it becomes R1 R2 over R2 plus R1. So this is the formula for the overall resistance in this circuit. Okay, now we can put that R here. That will give us the current. So if we do that, we're now going to say that what current is voltage divided by resistance. So that will be V divided by this R, which is R1 R2 over R2 plus R1. Now if I change this to multiplication, this will be reciprocated. So this is equal to V times R2 plus R1 divided by R1 R2. So I've gotten my current. Current is equal to this. That's overall current flowing. Okay, so let's write that properly as our equation 1. So therefore I is V open bracket R2 plus R1, okay, divided by, this is R1 here, divided by R1 R2. So that's the current flowing. Now let's go back to our circuit and do some analysis here. Now in our circuit, if we want to get the current I1 here, Okay, if I1 is there, it means it will be this V, because V is the same thing across here and here. So I1 will be V over the resistance along which I1 flows, and the resistance along which I1 flows is, and the resistance is R1. So here becomes R1. Okay, so we can now write a second equation for I1. We can now say, but I1, which is actually V over R, will now be V over R1. Okay, this is I1. So this is it. Now, if you look at this closely, you can see that I can make V subject of formula from this and actually put it in here. Okay, so if I analyze this now and I make V subject of formula, I will get that by cross multiplying to clear fractions. When I cross multiply, I have I multiplied by R1 R2 equals to V open bracket R2 plus R1 close bracket. By the time I make V subject by dividing both sides by this, I will now have that I R1 R2 divided, okay, by R2 plus R1 equals to the voltage. So this voltage, I can put it in here. That will give me I1. So when I do that, I'm now gonna have, so therefore I1 is equals to V. This is the result for V. So I have it as I R1 R2 all over R2 plus R1 divided by, okay, that's divided by R1. So I have this as R1. If I change it to times, it becomes the reciprocal, which is 1 over R1. So we're getting close to our formula now. So I1 is equal to I R1 R2 divided by R2 plus R1 times reciprocal of this, it becomes 1 over R1. If you check closely, this can cancel this. So our formula now is I1 is equal to the current I, which is this, multiplied by, open brackets, R2 over the sum of this. So I have it as R2 plus, okay, R1. So this is the current divider rule. Okay, so the current flowing across resistor R1 is the main current, the incoming current, then open bracket, the ratio of the second resistor divided by the sum of the two resistors. Okay, so that's current flowing through the first resistor R1. So if I want to get I2 similarly, I will now say I2 is equal to the main current multiplied by the other resistor, which is R1, divided by the sum of the two resistors, R2 plus R1. Alright, so this is what is called current divider rule. It helps you calculate the branch current when you know the main incoming current and you know the values of the two resistors. I will show you the application of the current divider rule in my next video. Okay, cheers.